Topic explains how portfolio theory provides the foundation for measuring and managing financial risk through diversification and statistical analysis. Modern portfolio theory demonstrates that investors can reduce unsystematic risk by combining assets whose returns are not perfectly correlated. The relationship between expected return and volatility becomes central to portfolio construction because investors seek efficient portfolios that maximize return for a given level of risk. Value at risk, VAR, extends these principles by estimating the maximum expected loss over a specified time horizon and confidence level. VAR became widely adopted in financial institutions because it translates complex portfolio risks into a single, understandable measure useful for risk reporting and capital allocation decisions. The topic emphasizes that portfolio risk depends not only on the volatility of individual assets but also on their correlations. Covariance and correlation matrices are therefore essential tools in portfolio risk measurement. Diversification benefits arise when asset returns move differently under changing market conditions, lowering total portfolio variance. VAR calculations incorporate these statistical relationships to estimate potential losses under normal market conditions. Institutions commonly calculate VAR using historical simulation, variance-covariance methods, or Monte Carlo simulation techniques. Each method possesses unique assumptions, strengths, and weaknesses. Historical simulation relies on past market data, while variance-covariance assumes normally distributed returns, and Monte Carlo simulation generates multiple hypothetical scenarios for future outcomes. The topic also discusses the practical interpretation of VAR and its limitations in financial risk management. A one-day 99% VAR estimate indicates that losses are expected to exceed the calculated threshold only 1% of the time under normal conditions. However, VAR does not specify the magnitude of losses beyond that threshold, creating concerns during extreme market events. The measure may underestimate tail risk when financial returns exhibit skewness, kurtosis, or changing correlations during periods of stress. Financial crises demonstrated that portfolios appearing diversified under normal conditions can become highly correlated during market disruptions. Consequently, VAR should be interpreted carefully alongside stress testing, scenario analysis, and complementary risk metrics. Topic also introduces coherent risk measures as an improvement over traditional VAR methodologies. A coherent risk measure satisfies four key mathematical properties: monotonicity, subadditivity, positive homogeneity, and translation invariance. These properties ensure that the risk measure behaves consistently and supports sound risk management decisions. Subadditivity is particularly important because it recognizes the benefits of diversification by ensuring that the combined portfolio risk does not exceed the sum of individual risks. VAR may violate subadditivity under certain market conditions, meaning it can discourage diversification in some cases. This limitation motivated regulators and academics to explore alternative measures that better capture extreme downside risks. Expected shortfall, also called conditional value at risk, CVAR, emerges as the primary coherent alternative to VAR. Expected shortfall measures the average loss occurring beyond the VAR threshold, thereby capturing the severity of tail losses rather than merely identifying a cutoff point. For example, if a portfolio exceeds its 99% VAR, expected shortfall estimates the average magnitude of losses in those worst-case scenarios. This characteristic makes expected shortfall more informative during periods of market stress and financial instability. Because it accounts for tail risk directly, expected shortfall provides stronger incentives for prudent portfolio diversification and more conservative risk management practices compared with VAR alone. The topic concludes by highlighting the growing regulatory importance of expected shortfall in global financial supervision. Banking regulators increasingly favor expected shortfall because it better reflects extreme losses experienced during financial crises. The Basel framework for market risk capital now incorporates expected shortfall rather than VAR as the preferred risk metric for determining regulatory capital requirements. Nevertheless, expected shortfall also presents implementation challenges because it requires larger datasets, more complex calculations, and greater computational resources. Risk managers must therefore balance theoretical accuracy with operational practicality. Together, portfolio theory, VAR, coherent risk measures, and expected shortfall form a comprehensive framework for identifying, measuring, and controlling financial market risks in modern institutions.